Yep. And we figured that out, you know, when you add up the two moments, you get positive 112, 0, 0. So that says we only have an x torque. Okay, so back to this. So now we apply that torque of 112 Newton meters. We have the distributed load from the weight. We'll figure out what that is in a second. And then we have the internal loads: tension, shear force, bending moment, and torque. And now for the distributed load, well, the total weight is 300. The total length is 0.2 meters. And so that distributed load function Q is just 300 newtons divided by 0.2 meters, which is 1,500 newtons per meter. Well, now that we've chosen a body to isolate, now we can represent that distributed load as a point force. So think of this rectangular distributed load as a rectangle with a height of 1,500 and a width of x, because we're just isolating this piece that's x long. The area is length times width, so 1,500x. The centroid is right in the middle. And now I can represent that distributed load as a point force, so I'll draw this again. We have the torque of 112. We have the force vector acting at the middle of 1,500x, the area of that rectangle. Then we have the tension, shear force, bending moment, and torque. Newton's second law says, so add up all the forces. Remember that 112 is a moment, that's a torque. So Newton's second law says 0, negative 1,500x plus P0 plus 0, negative V. I'm just going to combine those into one vector. You can always do that. Is equal to zeros. So T is equal to 0, and V is equal to negative 1,500x. And now the moment equation about the z-axis. So these things, what would produce moments about the z-axis? Here are the lengths we have. So this distance is x over 2. This distance is x. And torque of 112 produce a moment about the z-axis? No, that's x. How about the 1,500x? Yes, and its moment arm is x over 2. So we have x over 2 times the magnitude, 1,500x. Our about point is at the left end, like it always is for internal loads. So would that force make it rotate clockwise or counterclockwise around the about point? Wrong. Negative. You'll get the next one, Aaron. And then tension doesn't do anything, torque doesn't do anything. So we have the things that always affect the z moment. For the internal loads, we have plus m minus vx equals 0. And so m is equal to positive 750 x squared plus Vx. And so m is equal to 750 x squared minus 1500 x squared, so that's negative 750 x squared. And then the moments about the x-axis. Okay, so what contributes to the moments about the x-axis? These are the easy ones because they're all just a couple of components. So we have the positive 112 plus that internal torque is equal to 0. So the internal torque is negative 112. Right. Yep. Any questions about those? So now we go to the second cut. Cut 2 is valid for x values between 0.1 and 0.2. So this time there's this much that we're not paying attention to. And then on the part that we are isolating, there's this fraction of the weight. There's the torque of 112. There is the 1,000 Newton force. And there's the reaction at the roller, which we calculated before, 300 newtons. And then the internal loads. Okay, so that's one of those things that it's like, it'll make sense and then it'll stop making sense and then you'll get it. Like, finally I get it. And then a week later, it'll confuse you again. So X is always referring to where the right end is. X doesn't have anything to do with the left end. So the cut, the piece we isolate, starts all the way at the left end and goes to X, where X can take any of those values. Okay. So this cut represents everything from, a piece that it always starts over here, but the right end can start just past this midpoint, or it can be just before here. But the thing that doesn't change is that we always isolate the whole thing from the left. X is the right end. Just think about that.
Everything to the left still affects what's in that cut. That's why you include it?
Well, you include it really just because if you didn't include everything there, you'd have to deal with internal loads on the other half too. You know what I mean? Like, there wouldn't be anything wrong with doing that, but then you'd have these unknown internal loads here. You'd also have internal loads on the other side, which you'd have to use your functions from before to figure out. It would just be unnecessarily hard to do. But there's no reason, you can isolate whatever you want. This is just the way to isolate it that makes it the easiest to calculate. Yep.
So since we're going all the way from the left, considering the 112 torque.
Yep, it's still in there.
Yeah, but should the range be from 0 to 0.2?
No, so that's what so this is the range of X values.
Yeah.
So just remind yourself that X is the right end.
Right.
X is the right end of the thing we're isolating. But we're always isolating a piece that starts all the way here and goes to X.
Oh, okay.
Okay. It always has a length of x, that's right.
But the
Yep.
range is
X is always telling you where the right end is. And then it's the same distributed load as before. That was 1,500 newtons per meter. And now that we've chosen the body to isolate, we can again represent that distributed load as a point force. It's not going to change. It's going to be the same as it was before. So we have a rectangle with a height of 1,500, a width of x. And so the total force is 1,500 x. Centroid is, x over 2 from the end. So I'll redraw this. We have the couple, the torque of 112. We have a point force right at the middle of 1,500x. We have a 300 Newton force acting up from the roller, and an external force of 1,000 to the left at the midpoint. And then the internal loads, E, V, M, and torque. And so Newton's second law says 0, negative 1,500x plus negative 1,000. I'm going to lump these two in to the same vector. 1,000 in the negative x direction, 300 in the positive y direction. Then t in the positive x direction, v in the negative y direction is equal to zeros. So t is positive 1,000. V is negative 1,500 x plus 300. And then the moment equation about z. Okay, so let's figure out some of these distances. The whole thing is x. From the left end to that 1,500x is x over 2. And then from the left end to where these two other forces are applied is 0.1. So we have x over 2 times 1,500x. That would be clockwise, so that's negative. Then we have 0.1 times 300. That would be counterclockwise, so that's positive. And plus m minus vx is equal to 0. So m is equal to 750x squared minus 30 minus 1,500x squared plus 300x. And so m is equal to negative 750x squared plus 300x minus 30. And then the last one is the torques about x. We have 112. It looks just the same as before because nothing applies a torque until you get to the endpoints. So 112 plus t is equal to 0. So the torque is negative 112. Any questions?
Now you can draw the piecewise function.
Yes, you could draw that function. Yeah, it's sort of a messy function. I mean, really, I'm never going to make you draw those by hand. Did I say this before? So, okay. So,
Or give diagrams.
yeah, on the homework, that's right. But on the homework problems, use Excel or like, don't worry about, you know, like in Calc 1 or Pre-Calc or something, you spend a lot of time trying to figure out how to plot these complicated. We're not doing that. Just find some software you like, plot those out in the software. On tests, you'll never have to do those graphs. Okay.